Okay, welcome in and greetings, everyone. Happy Friday. I hope everyone is doing well. I am going to be working on my board today. No better time than a Friday evening to do some math. And have decided that I am going to work with some quadratics. So go back to quadratics. So I'm trying to remember everything that I can about quadratics. And so again, remember, I encourage viewer participation here. So that's why I'm here. So if there's anyone out there that has a math problem, and I can't promise you that I can work it, but I sure will try. So feel free to post in the chat. And yeah, so I'm just going to go ahead and get into it and do my best to try to do a good job presenting how to graph a quadratic equation or a function, rather. And I picked a equation from this textbook that I've been working with. It's an older, obscure textbook that I picked up at a garage sale somewhere years ago, and got it out of the closet, dusted it off, and then going through it a little bit. And it's pretty good. And anyway, I found a quadratic equation that I want to work with, and let's see how this goes. For some reason, my marker's squeakier at the top than it is in the middle and the bottom of my board. So I wonder if it's the cleaner. All right, so everything I know about quadratics. So they're in the form, let's see, ax squared plus bx plus c equal 0. Or I'm going to back up and say it's y equals. I'm not going to say equal to 0 yet. So we have this function y equals, and we'll say y equals f of x. And then we can go ahead and replace y with f of x. And we can be interchanging them. So f of x. And what this is it's a second degree polynomial, and it's known as a quadratic. So we'll put that in there. Second degree polynomial. And so there is a potential of 2 solutions. So you can have at most 2 solutions, because the exponent, what it does is it tells you how many potential roots there are. And a root is a solution. So polynomials get complicated, and you can have a 6th degree, an nth degree polynomial, but what that's telling you is there are at most that many solutions. So there's 3 types of solutions. 3 types. You can have a situation where you have 2 solutions. One solution. Let's see if I can spell right today. Or no solution. Okay, and what do I mean by solutions? Okay, let's attach it to a graph. What we're talking about in solutions to quadratics is where specifically it's crossing the x-axis. So you have plus minus, you have your x comma y, and you have two clean intersections. This is what I mean by two solutions. One solution means that it's just resting on the x-axis. So it would be like this situation. And I realize I'm lefty, so can't see what I'm writing, but it's just resting there. And so there's only one intersection. And then you'd have a situation, let me scoop this over a little bit. Hang on, let me redraw this. I'm gonna put that in there. Okay, so one solution. It's such a big deal. Okay, so we got minus, plus, I'm not sure x and y. And we've got that one intersection. And it's just resting on the x-axis. So, let's see, that's the y equals 0 line. So you're going to have some point A, and it's going to be A comma 0. And then you can have no solution. Okay. And what that means is, it means that it's not touching the x-axis. They'll have some other values going on here, but it's not crossing. It's up here somewhere. Okay. Okay, very good. And then this one will be A, B, and you have all right, so it's nice to know before you start solving and finding values exactly what kind of, solutions you're looking at, especially when you're dealing with multiple solutions. And what do I mean by solutions? Solutions are the zeros of the function. Okay. All right, so I picked one that I want to work with out of this textbook, and it was just out of the examples. And all it's asking us to do is use the quadratic equation. So for solving quadratic equations, there are three different ways to solve a quadratic equation. And the easiest method is if it factors. So you always want to see if it factors first. If it doesn't, then you've got the quadratic formula, and then you've also got the completing the square method. I want to try to practice all three with this this function. And so let's see where I want to write the function that I want to work with. Okay, it is y, so here's an example. Y equals 2x squared plus 3x plus 1. And this function is asking us to use the quadratic formula to solve it. However, it does factor. So when you want, so I want to go ahead and find, I'm going to go ahead and draw my graph, my Cartesian coordinate system. Okay, and I want to find those critical values to sketch the graph of this function. Okay. The very first thing I want to know is I want to know where it's crossing the y-axis and the x-axis. I want to know those two critical values first. So I'm going to build my table. See, we'll put it over here off to the side. Okay. Build my table, get my values in my domain that I want to check. The very first thing I want to do is find out what my x and y intercepts are. So I'm going to plug in 0 for x and 0 for y. So which one you want to do first, let's go ahead and check and do the y-intercept first. So the y is going to intercept when x is 0. So I'm just going to take my function y equals 2 times 0 squared plus 3 times 0 plus 1. Just plugging in 0 for x. And I'm going to get a y value of positive 1. Okay. So when x is 0, y is 1. Okay. And so then I'm just going to calm down and take a break. And relax and try not to get in too big of a hurry. Okay, so we've got our first critical value is when x is 0 right here, and it's going to tell me that I've got this function intercepting the y-axis at positive 1. So that's a value that's on the graph. I'm now going to set my function equal to 0, and I'm going to solve for my my x-intercepts. So where is it crossing when y is 0 now? So just plugging in 0 for y now, you have 2x squared plus 3x plus 1. And this is where you would have to find the solutions, the zeros of this polynomial. And if you didn't know that it factored, or you didn't know how to factor it, you could use the quadratic formula. However, it does factor, and I was able to recognize the factors, but factoring takes practice. So when I saw this example, I thought it was a good one because it factored. So what you're doing is you're reversing. So you want to put So maybe some other day I'll try to explain factoring. It's really hard for me to explain, but I want to check it. So it's 2x squared. So it's a reverse process of this first, outer, inner, last, where you're taking and you're systematically multiplying these binomials. So you've got 2x times x will be 2x squared, making my first term. And then 2x times 1 is 2x. And then you go to the second term and you multiply there. 1 times x is plus x. And 1 times 1 is plus 1. So when I simplify and combine these like terms, I'm going to get 2x squared plus 3x plus 1. And so I was just checking to make sure that I found the factors correctly, making sure that I get my polynomial back. And I did. Okay, so here are my factors. I might get into the quadratic formula maybe next week, because right now I just want to graph this polynomial. Okay, so we have this going on. We have these two factors set equal to 0. So what we're going to do is we're going to take each individual factor and set them equal to 0 to find the actual values for my domain that it's crossing the x-axis. So we've got 2x plus 1 equals 0, and we've got x plus 1 equals 0. Both of those. So the first one, we're going to subtract 1 from both sides. So that's going to be 2x equal negative 1, and then divide by 2. So for this one, I've got x equals negative 1/2. Okay. So we've got negative 1/2. So we've got x equals negative 1/2. And then subtracting 1 from both sides here, this is x equals negative 1. So we've also, here, we put negative 1 first. So we'll go negative 1, 0, negative 1/2. Oh, silly. Negative 1/2. And then 0. And we'll do 1/2. And then 1. Okay. So we've got our two critical values. So we've got our y-intercept at 0. What was it? At the 2 points, we've got negative 1 comma 0, and we've got negative 1/2 comma 0. 1 comma 0, and we've got negative 1/2 comma 0. Those two. So I'm going to erase all this work. And I can even erase this too. And I'm going to go ahead, and so I have something going on. It looks like in the second half of so it's second and third quadrant for this graph, and then it goes into the first quadrant. So I'm going to start out by putting those two values on my graph. So we'll say that's negative 1/2, negative 1, negative, what's that? It's 3/2, negative 2, 5 halves, negative 3. Is that right? Let me check my math. I'm over here doing mental math. Not good. Okay. So 3, I know 3 and divided by 2 is 1.5, but it's 5 halves 2. Yeah, okay, good. All right. So that'll work. Negative infinity. All right. So we've got our critical values here. Let's go ahead and just list some more values in our range. Let's see, 1, 2, 3, 4, 5, 6. And go down here, -1, -2, 3. And it's a rough sketch, so it doesn't have to be perfect. I need to remind myself that, and I had a little bit different scale, so I want to be symmetric in my scale here. So I'll get a little ahead of myself. 1/2, 1, 3 over 2, 2, 5 halves, and 3. Good. All right, so we found at -1 it was 0, -1/2 it was 0, 0 it was 1, and then we don't know about 1/2 and 1 yet. We'll plug those values in. Okay, so we've got, and I want to use the red to graph it. I noticed that I liked it. I liked the red. Right, so we've got this critical value right here on the y-axis, and we've also got a 0 here at -1/2, and we've also got a 0 at -1. So that is a really skinny function. Just check. Okay. And then also I could plug that in to my graph and check it. More importantly, I found the equations for the coordinates of the vertex. So there, it gets pretty complicated, and there is a vertex form, and maybe we'll get into those too if I can go and remember them and write them out over the weekend. But for now, I just want to find a couple more critical values and introduce this, the vertex form, or just the coordinates of the vertex. So there's a formula for that. So formula for vertex. And the vertex is the, it's the lowest point if it's opening up, and it's the highest point of the graph if it's opening down. So if your quadratic is in this form, ax squared plus bx plus c equals 0, then you have the coordinates of the vertex is at -b over 2a, comma, -b squared minus 4ac. Hold on. -b squared minus 4ac over 4a. Over 4a. And I am not that much familiar with that, but we can still plug in and find that critical point this way. And then there are other ways of finding it. Okay, so -b minus 4ac over 4a. Got it. So all you're doing is taking your quadratic and putting in that form by setting it equal to 0. So you have 2x squared plus 3x plus 1 equals 0. So you just say a is 2, b is 3, and c equal 1. And then you use that form, you're just plugging in. So for the x coordinate, you have negative b over 2a. 2 times 2. So it's saying your x coordinate of your vertex is going to be at negative 3/4. Negative 3/4 is on there. So I would put it, probably scoot it in here somewhere, put it in the table. We'll put it in there in a minute. Negative 3/4. And then I'm going to circle that, and then we'll work out the y coordinate here. So y is going to equal negative b squared. So negative 3 squared minus 4 times 2 times 3. And that is going to be over, hang on. Yeah, 3 squared minus 4 times 2 times 1. I knew I was going to mess something up. All right. Okay, so it's 4 times a times c over 4 times a. Okay, got it. So then we're just going to simplify using a little bit of algebra. And remember, order of operations, you're going to handle whatever's inside the parentheses first. 3 squared is 9. And then you're going to do your exponent first. 4 times 2 is 8. Times 1 is 8. And so it looks like 4 times 2 is 8. It's 9 minus 8. So it's a negative 1/8. Okay, scoot that in there. It's an odd way to make a table, isn't it? Negative 3/4. Okay, negative 3/4, comma negative 1/8 is where your vertex is, and then it was negative 1/2, and then we had 0, and then we had 1 and 2. So we'll do 1 and 1/2. All right, so negative 1/2, that was at 0, that was 1, that was 0, and then let's check one more point just for fun. All right, I am going to, so I've got these two values that I needed already. I am going to erase all this, and let's evaluate this function at one more value just to get a symmetric graph. We're going to put it, actually, let's do 2 more points. Let's do positive 1/2, positive 3/4, and we'll do positive 1. And that'll be good for me. So that was positive 1/2. Yeah, okay. So all I'm going to do is I'm just going to plug in my function for x at 1/2. So we use f of x, and we'll say f of 1/2. And so that's going to be 2 times 1/2 squared plus 3 times 1/2 plus 1. So all I'm doing is plugging in, because I want to know the behavior of the function when x is 1/2. So I want to get that critical value in my graph. Then what I'm going to do is I'm going to plug in 1/2 and see what that function's evaluating at. So we're going to remember order of operations. We have to handle the the exponent first, and we're squaring the numerator and denominator. So this is 2 times 1 squared is 1, and 2 squared is 4. And then that's plus 3 times 1/2. When you multiply a whole number by a fraction, the 3 is going with your numerator. So it's just 3/2 plus 1. And then 2 times 1/4. The 2 is going to go in the numerator. And then I'm going to simplify that down. So plus 3/2 plus 1. So a real quick way to add these fractions, well, I could just put it all over the denominator 4, or I could reduce that 4 down. It doesn't matter, we'll just do it this way. So that's going to be 2. 2 times 2 is 4, so 3 times 2 is 6. And then 4, so that's over 1. So 4 times 1, so that's plus 4 for all three of those fractions. So that's 10 plus 2 is 12 over 4. And then we know that 12 divided by 4 is 3. So when x is 1/2, y is 3. All right, let's repeat that process. I'm going to erase this one, and we're going to move it down here because I think it's a little bit better down here. So we've got of 3/4, f of 3/4. So that's 2 times 3/4 quantity squared plus 3 times 3/4 plus 1. Okay, good. All right. And again, what we're doing is we're going to square this fraction. So we're squaring the numerator and squaring the denominator. We'll multiply it in the next step. So 3 squared is 9, and 4 squared is 16. Okay. And then we could go ahead and multiply this one out. 3 times 3 is 9, and you're going to keep your denominator. Okay, and we got to get good at fractions. Okay, so don't be scared. Don't be scared of fractions. So 2 times 9 is 18, and that's over 16. And then I have 9/4, and we have plus 1. Now, it might serve me to go ahead and simplify this. However, I'm not going to be able to simplify it down where it's going to have a common denominator. So we could just use 16 as the common denominator if you wanted to. We'll get a big fraction. It's okay. We'll reduce it later. So we have 18. And then, so this is going to, 4 times 4 is 16. So 9 times 4 is 36. And then this one's going to pick up a factor of 16. So that's going to be plus, let's see, 1 times 16. And then we'll add all those numerators up. Let's see, 18, 16, and 36. So that's 12, 20, and then 3, 5, 6, 7, 70. 70 over 16. And then usually I have someone doing math with me. That way they can double check my numbers. But I'm doing math all by myself. So 70 over 16, I better double check in my calculator. All right, before I go reducing this thing down. So I think it's really important to practice all of the small steps within the context of a much more complicated problem so that you see the relevance of the algebra. It's like, what am I learning all these algebra rules for? What is the relevance? Yeah, 70 over 16. All right, so good. I'm doing math on a Friday night and I didn't make mistakes. All right, so that's 7 times 10. When you're reducing fractions down, what you're doing is you're splitting it up into its prime factorization and you're going to reduce down anything that you can. So this is 2 times 2 times 2 times 2 is 16 because it's a base 2 number. And then it's 7 times 10. So it's 7 times 5 times 2 is 70. So we can only cancel out a 2. So this is going to be 7 times 5 is 35 over 8. 35 eighths. So at 3/4, it's 35 eighths. And then 70 divided by 16. Math fraction form. Yeah, 35 eighths. All right, and let's do one more, and the one won't be too complicated. And I'm not risking, I don't have any questions. I don't have any participants. So I'm literally just in YouTube land working with my camera, hanging out by myself. It's okay. All right. It's really good for me. And so I'm really excited to be doing this right now. If I didn't have the camera, I'd probably just be doing the math by myself and no one would ever know. All right. So one more value, we're going to so we can have a symmetrical graph, we're going to plug in f of 1. And this should go a little bit quicker because we won't have any fractions. And 1 is one of my favorite points to evaluate for any function just because it's so easy. 1 is easy peasy. So 1 squared is 1 times 2 is 2. 3 times 1 is 3. And then just 1. So it looks like we got 6. All right. Let's go ahead and plot these points so we can wrap it up. 40 minutes in, not too shabby. Okay. All right. Our first one was, so I've got a couple of them already here. Oh yeah, I was going to do it in red. Good. All right. I'll do it in red here. So we've got -1, 0 on there. We've got -3/4 is like right in here between 1. And that's at -1/8. Ooh, that is really close. Just say it's right there. Almost touching the x-axis. -1/2, 0 is on there. 0,1's on there. 1/2, 3 is on there. 3/4. What's 35 eighths? 4.375. Is that right? Hang on. 35 eighths. Yeah, it is. It's already off the graph. So I should have done something over here. So anyway, here is my quadratic function here. Here is what it's doing. the critical values. And I guess, so by the time we get out here, there really isn't any point. Looks like maybe 1/2, so 3/2 is probably on there. Let me just plug it in real quick. I'll plug in -3/2. So -3. Squared plus 3x plus 1. And it's saying it's +1 again. Okay, so that makes sense. So it's saying 3/2, 1 is on there. Good. So we should have, wait, 2, I wonder if 2, 3 is on there. Hang on, let me plug 2. No, it's at 15. So by the time it gets to 2, it's already at 15. So this baby is really wide. So what it does is it just shoots up that way. So 3/2, hang on. 3 divided by 2. So yeah, so that one's already at, by 3/2, it's already at 10. 10's not even on there. So it's like this. Yeah. All right. And then we'll go ahead and just we gotta cut it off at some point, so we'll just say right there. All right. Not too bad. Okay, so quadratic equations. Probably spend some more time on polynomials, and the probably good solid week I can do on polynomials, because we'll start out with first degree and then go into the second degree, which we're in now, quadratics, and we'll spend some time on quadratics, and then we'll go into the cubic and the quartic graphs. So that's, yeah, at least a week of material for polynomials. So again, if you have questions about math, or if you want to just come and hang out and do some math with me, that would be awesome. I am Professor L, and I am doing this project, hosting a live stream Monday through Friday from 6 p.m. to 7 p.m. Central Time. And yeah, I'm going to do it just to practice working on my board and open it up to the public to see if anybody wants to hang out and maybe possibly do math with me. That would be awesome. Anyway, so thanks again for watching my videos, and thanks again for yeah, any kind of feedback that you might have. Keep it fair. And again, thank you so much for watching, and I will be back again Monday, and I'll see you next time. Bye.